Welcome back to Archaeology After Dark, everyone. I'm your host, Daniel Rhodes. My guest today is Dr. Emily Lindsey. Emily, thank you so much for joining me.
Thank you for inviting me. I'm happy to be here.
Awesome. Tell us a little bit about yourself.
So, I'm a paleoecologist, which means I'm a person who studies kind of ecosystems and how different plants and animals, species interact with one another and with their environment. But I do this in ecosystems that don't exist anymore, ecosystems from the past. I mostly focus on the Pleistocene, which we colloquially call the Ice Age, which is the last time that most of the world was kind of dominated by large mammals. And I specifically look at the extinction event when the vast majority of those large animals disappear, which happened at the very end of the Ice Age. And, to this day is like the single biggest extinction event since the dinosaurs.
And that brings us to what we're talking about today. So, we're talking about megafauna and how they relate to people and both the fall of species and the rise of humanity. So, there is a connection between the two. Am I right?
There is, and this is something that I've been thinking about more and more, as kind of my research has progressed and, different studies keep coming out. There's always been this debate, like for the last 70 years or so, about, whether the climate changes that were happening at the end of the Ice Age, were more important in driving this big extinction event than the human populations that were spreading around. And really, to some extent, both processes were involved. And it's really important, I think, to understand exactly how those two processes were involved and exactly like mechanistically how the extinctions actually came to pass in different places. But if you look at, the story of the last 50,000 years or so, it's really the story of humans and human domesticated animals just proportionally replacing other large-bodied animals over this time transgressive period. And that's how we get to the point where we are in today. We go from a point where basically every ice-free continent on Earth looks like the African savanna to the world that we're living in today. And it's probably because we don't have all of these large-bodied species, uh, occupying these ecosystems anymore, that humans were really able to develop the society that we did, right? Like all of the kind of major innovations, agriculture, complex societies, large scale city states, all of these happened in the context of a world that had become dominated by humans and had lost the vast majority of the other large animals. So I think, you know, the underlying story is that humans are both the drivers and the beneficiaries of this extinction event. That being said, there are a lot of ways that you know, region specific environmental processes and, these very significant climate changes that were happening at the time played a role as well.
Well, also, I would assume that each region would be different. Like some regions hadn't been populated by humans yet. Like since they came down from Alaska, I figured the places that were closer to that would be affected more, I guess, impactfully, just because those were the first places reached than, say, where I am in Alabama, where people have only been here, 10,000 years or so, give or take.
Yeah, there's you certainly see the extinctions on a broad brush scale kind of correlate with human arrival. So humans arrive in Australia about 60,000 years ago, and that's where you see, a really early wave of extinctions. You see a much longer cohabitation between humans and other hominids like Neanderthals in, say, Europe, along with the megafauna, and then you see more of those extinctions happening as human population is growing, but also as the climate is changing. In terms of Beringia, yeah, it does look like the extinctions happened earlier there. Um, but once humans, kind of make it past that ice barrier, like, I used to think, wow, like it's really strange that we have, evidence of humans down in like Patagonia 14,500 years ago, which is barely, that's not much longer, much later than any site in non-Beringian North America. But then if you think about it, like people can hike the Pacific Crest Trail or the Appalachian Trail in like 3 months, right? Like people move very fast when they want to move, and probably, humans that 15,000 years ago who were basically itinerant hunter-gatherers could move a lot faster than us slowpokes today. So it shouldn't really be that surprising that humans migrate really rapidly and modify the ecosystems where they arrive pretty rapidly when they want to.
Well, I would imagine these species, just because they are so large, that means they also have a large impact on the environment. And, people seeing this giant animal would probably be deterred from settling there. Like you see a giant, like saber-toothed cat like that prowling around, you're like, well, this probably isn't the best place to live.
Yeah. Yeah. I mean, you want to go away from where they are or you want to make them go away from you. And so, we don't have a lot of direct evidence of humans hunting the large carnivores, but I imagine they probably did. I certainly would if, me and my family were trying to camp in the cave next door to the saber-toothed cat cave. I'd probably go after them and try to drive them out or kill them off. We know that humans' most powerful tool we've ever invented is fire. And humans certainly use fire very intentionally to clear areas, both to facilitate the growth of particular plant species, to improve hunting, to maintain, open areas for camps, but also to drive away animals that they didn't want around there or make it harder for those animals to hide.
Yeah. And I guess, as technology kind of evolved, so did humanity. And that caused, an impact on the species as well because we developed sharper, pointier things to hunt them with.
Yeah, there's certainly, cultural and technological innovations, I think, definitely are an underappreciated factor. Certainly by paleontologists. When I talk to archaeologists, obviously they're much more aware of the importance of culture and, culture not being static and humans, not really being able to be treated just as, an optimal foraging animal in the same way that we do other organisms. And so I think there's something to that as well. The innovation of the Clovis technology, which is, this very large spear point technology that's clearly designed specifically to hunt large game, probably, was influential in some of the ecological changes that we see as well.
So, my question is now, seeing this from a historic standpoint, how can we translate that information to something we can learn from now? Like, how does it impact the way our environment interacts with species now?
Yeah, that's a really good question. And that's something that, I think a lot about in my research. So, the biodiversity crisis that we're in today, where there's a lot of species that are currently threatened by largely human activities, mostly habitat loss, some extent hunting and poaching, and also human-driven climate change. Um, this is a continuation, really, of the extinction event that began 10, 20, 30,000 years ago in different parts of the world. Like that the extinction of the Ice Age megafauna is really the initial pulse in this sort of extinction event that may or may not become a sixth mass extinction event. But it's the first one that's really driven by another species, right? And that's us. Like there were continuing extinctions throughout the Holocene, and then we see extinction rates ramping up again today as human population continues to grow and put pressure on these last remaining ecosystems. when I was a kid in school, I remember, human population was 4.5 billion, and now it's almost double that. That's just in, kind of my sentient lifetime, right? Like we're growing very fast. We are increasingly using up resources, and that means there's less resources for other animals to use. And I think, um, having this deeper time perspective provided by paleontology and to some extent archaeology can be useful as we think about conservation questions today, both because it can give us an idea of, how, like on a very granular level, we can look at how climate changes in the past have impacted species, including species that are related to ones that are still alive today. Like we can actually track movements across from when we go from a point where like half of North America is under an ice sheet to today, like that's about um, 5 degrees Celsius temperature change, and that's about what we're looking at today, only in a much shorter period because of human-caused climate change. But it also, until you realize that, for about 50 million years, most of the world was dominated by really large bodied mammals, and it's only very recently that they're gone. You have a really different understanding of kind of ecosystem stability and roles that may have been lost, and maybe how humans have stepped into those roles in some ways, and ways that we could act to help maintain ecosystem function in the absence of these large-bodied ecosystem engineers, if you will.
So what's the solution there? How can we as people step in to fill that gap, I guess, that's left behind?
Yeah, so one example, and I'm going to go super local here because this is what I know best. So I live in Southern California. Um, I work at the La Brea Tar Pits, which is the richest Ice Age fossil site in the world. We have dozens of species of large animals that went extinct very rapidly, it turns out, just about 13,000 years ago. Um, what we discovered through some research that we did here, which involved a lot of radiocarbon dating, is that that extinction happened almost synchronously, right about 13,000 years ago, and B, that this extinction coincided. It followed a period of about 1,000 years or so of very intense climate warming and drying, not too different from what we see today. Uh, but it coincided with this tipping point that was catalyzed by widespread wildfires. And we had, so we go from a point where for like 20,000 years, there's little to no evidence of fire in the record, to about 400 years of really elevated fire, like an order of magnitude more fire happening than had ever been in a record that we had here. And across that period, that's when all the megafauna go away. It happens to coincide with a time, sort of this inflection point where human population is rising very quickly in North America. Um, and it also coincides with this whole scale ecosystem turnover where we go from something that's more of like an oak juniper woodland savanna to the modern chaparral ecosystem vegetation that we have here in Southern California today. Now, a couple of things about the chaparral. One, it's fire adapted because this is the first time fire has appeared in the system, and so it kind of selected for these plants that do really well in the context of fire. Um, but it's a very dense kind of vegetation. And if you don't have large animals kind of walking around and breaking up your dense vegetation assemblages, it becomes very difficult to have a human society there, right? And so humans, it seems like the earliest humans that occupied this area in sort of a, permanent kind of long-term context, figured out how to use fire after this period, after the extinction of the megafauna, to actually manage the landscape. Um, and they were doing that, they probably for like 12,000 years, the indigenous residents of California were like very effectively and very skillfully managing the landscape with fire to create these open areas that would have previously been created by the megafauna, by the large animals. Um, and that does a couple of things. When you have an intermediate disturbance like that, it maintains higher levels of biodiversity. It also creates these open areas where you can hike, you can hunt, you can keep predators away, you can create your camps. It regenerates the landscape because you're putting carbon back into the ground. It can select for certain types of plants to grow that you prefer. Um, and it also prevents really large scale fires because you don't have this buildup of like dense vegetation altogether. Um, I don't know if you've heard, but like Los Angeles has a real problem with fire today, like really large fires getting out of control. And that's probably because we don't have megafauna anymore, and we don't have humans managing the landscape um, to prevent those large scale fires from happening. Right. And I think, if you were just dropped into Los Angeles today, or even like 50 years ago going forward, you'd be like, huh, we didn't used to have this problem, with fire, and now we're having like almost yearly, kind of deadly, incredibly expensive large scale fires. What's going on? And the answer is like nobody is managing the land to prevent fire anymore, right? Like for tens of thousands of years, we had mammoths and mastodons and giant ground sloths managing the land in a way that prevented, this large scale vegetation buildup. And then for another 12,000 years, we had humans managing the land in a way that prevented, these conflagrations. And now nobody's doing that. But we only know that because we have those deeper time records provided by the archaeological and the paleontological record.
So, just by listening to what you've said so far, it's kind of hard not to see things as like a cyclical pattern, like things repeating themselves over again. Like there's the period of wildfires then, there's the period of wildfires now, only the environment has changed to not prevent the fires.
Well, it's certainly history repeating itself in a certain way. Yeah, and interestingly, so here's the thing that we were surprised to learn that was really interesting about Southern California is like um in coastal Southern California, we don't really get lightning. So all of the fires, today and the probably the fires 13,000 years ago are all human ignition sources, right? Today it's down to power lines, it's vehicle emissions, it's campfires, not getting fully put out, right? Fireworks being set off in places where we shouldn't be setting off fireworks. Um, and that's really telling, right? Like this is not an area where we get lightning strike fires. Other parts of California, sure, like the Sierra, there's lots of places where they do have these, naturally occurring wildfires that you can't control. But here, it's really all us. And if we cause something, we should be able to prevent it.
Yeah, we really should be. Okay, so this is the PSA for this episode. Be more responsible when maintaining fires outside, and please don't start them because the last thing I want is getting emails saying, "Hey, Daniel said it was okay to start fires outside." Just don't start fires. That would be great. So, how do you uh, get new evidence for research like yours? Because, I imagine that fossils only last so long before they're, literally just dust. I've seen fossils, I've picked one up and it has crumbled in my hand. How do you add to what you already know?
Well, so the La Brea Tar Pits is a very unique site. where we have not only just a huge fossil record, but we have a variety of fossils that is almost unprecedented in other contexts. So normally, at a fossil site, like you're either going to find something like a bone bed, which might be, a bunch of large bones of large animals that have maybe all been washed together in a fluvial setting, but anything smaller has been washed away, right? Or conversely, you might have a really low energy setting, maybe a stream eddy or maybe a raptor midden in a cave or something where you're getting a bunch of small material collected together, but not the big stuff. It's also pretty unusual to get plant material like wood and seeds and leaves preserved alongside bones because wood preserves in more acidic media and acid dissolves bone. So you don't usually get those together. The tar pits captures everything. Like everything sort of gets indiscriminately stuck in tar pits. And then the asphalt is such a good preserving agent that we have everything from like insect wings and uh, little shells and acorns all the way up to mammoth bones, right? So we get everything collected together. And the asphalt is so good at preserving material that it doesn't, with some exception. I mean, we have a variety of contexts, but by and large, the fossils that we pull out not only are in excellent condition, not only are they not falling apart, but they're actually still the original bone. They haven't become permineralized. They're still the original material, bone or wood or what have you, which means we can get precise radiocarbon dates off of it. We can uh, do chemical analyses to understand something about the diet of an animal or the environment an animal or plant was living in. So it's just this kind of remarkable substance that we have that is really good at preserving this unique fossil record that can tell us so much about what it was like here in the past.
So the tar pits actually slow down the fossilization process.
Sorry, say that again.
The tar pits actually slow down the fossilization process.
Yeah, they prevent, I mean, oil and water don't mix, right? So the asphalt is essentially a component of crude oil. It prevents the movement of water through the deposit and through the bones. So normally the way fossilization or mineralization happens is you have water trickling through the land, it's picking up minerals, and then it goes through the bone and it deposits, it's kind of eroding away, dissolving away the bone material, the carbonates, and replacing it with a mineral that it had picked up going down. But we don't have that process happening in the tar pits because the oil prevents it. The oil also prevents microbial action that would normally decompose all of these materials. So it's just, it's very anoxic. It's pretty low in terms of microbial diversity and activity, and it's not allowing water to leach through. And so it's just preserving the raw material of the organism that was trapped there tens of thousands of years ago. It's really cool.
So my question about that is, how do you extract something from the tar pits? Because it's not like you can use ground penetrating radar or something because it's not a solid surface, right?
Well, it's mostly solid. It's sort of a viscous, slightly viscous solid. So the way the tar pits are, I think people, what's recapitulated in the media a lot is that we're these like bubbling pits of like oozy liquid oil, and that's not what it is at all. It's really um asphalt saturated sediments is what the fossils are preserved in. So if you imagine if you took like a terrarium and you filled it with sand and gravels and silts and clays, and then you like dumped a bunch of molasses on it, right? Like uh, it's still sediment. It just has that liquid saturation to it. So it is viscous. You do get on the surface these pools forming where the asphalt seeps are. So you have these sort of shallow pools of asphalt, but below that, the deposits where the fossils are really sediment that is saturated with asphalt. So it's messy. If we're digging in the ground where an active seep is, we'll put up sort of catwalks over the fossil deposit and then, sit or lie down on those boards and excavate that way. But there's only a thin layer of liquid asphalt, and otherwise it's just it's quite similar to archaeological research,
But
honestly.
it is
Just very
hot
messy.
though. It is hot though, right?
No, it is not hot. No, it's not geothermal.
Okay.
It is common misconception. So the bubbles, there are bubbles that come up, and a lot of people see those and they think that it's geothermal, but it's actually gases, natural gas that co-occurs with the oil deposits underground. So it's like sulfur and methane. Um, it does, it heats up in the sun because it's black and gooey, but it's not geothermal.
So if people wanted to learn more about the tar pits or megafauna or paleontology in general, what would you recommend that they look at?
Well, we have a lot of resources on our website, tarpets.org. So you can certainly go there and learn a lot more about our site and our science. Um, there's a lot of good sort of popular articles that have been written about scientific papers that have gotten published. So there's a lot of just lots of exciting research that's been going on as people have come up with new chemical techniques and new types of studies. So ancient DNA is an exciting thing where people have been able to learn more about the evolutionary history and population biology of extinct species. Um, Strontium is a new isotope that people are using to understand where individual animals have migrated across their lifetime. And then, of course, near and dear to my heart is starting to look at a real granular level, like the extinction event and what caused it, and um, how those processes are similar to or different from processes that we see going on today.
And if people wanted to actually get involved in the research that's going on in the field, not like just getting up from where they are right now and going out there and starting to dig, or yeah, because that's illegal. Don't do that. I can't tell you how many times I have to tell people that's not okay. What would you recommend they do? I assume that they could come volunteer at the tar pits. I probably should have looked at that first.
We yeah, we have a big volunteer program, but I'm sure, you have a wide viewership. I would say, the best thing to do first off is reach out to your local museum. There are museums, wonderful museums all around the country that have great collections of fossils and often great scientists at them doing research, archaeological, paleontological, and that's a really good way to start getting involved to see what sort of programs might be offered there. Either volunteer programs at the museum could be working in a lab, or it could be, sort of helping to prepare material. It could be working as a docent and communicating science to visitors, but often museums, especially during the summer, will even have field projects where they take museum staff and volunteers and students out into the field to work on digs. So I'd say wherever you're living, find your local museum, whether it's a historical society or a natural history museum or uh, just a local county museum, and find out what opportunities there might be there to get involved.
And don't be scared to reach out to people. More often than not, they are thrilled to have the help because there are always things to do, especially like for a nonprofit organization. Everybody needs help.
Yeah, absolutely. Absolutely. Especially right now, a lot of museums funding has gotten cut. And so they could really use support with a lot of their work probably now more than ever. So
Yeah. So if you get a chance, reach out to your museums, historical societies, your local archaeological society, and we are always happy to have volunteers. In fact, my career started out volunteering at a natural history museum here in Alabama. So there's opportunities everywhere, folks. There's no shortage of things to do.
Absolutely.
Well, Emily, it has been an absolute pleasure having you on the show. Thank you so much for joining me.
Thank you very much for having me. It was delightful and best of luck with your work.
Thank you. And thank you again for sharing yours with us and uh, continued fossil hunting. Because I don't want to encourage you to make more animals extinct. That seems wrong.
Maybe mosquitoes.
Yes, especially here in Alabama where the mosquitoes are the size of birds. If you see those here, feel free to take those out as much as you want to. All right, that'll do it for us here, everybody. Thank you again for tuning in and stay tuned for more.